Hello, today is another lesson on solving percent problems. It's section 5.6 in your Big Ideas Math textbook. And today we're going to be looking at some percent problems that involve the whole part of the fraction missing. And so remember, a percent is a part to a whole relationship. And so I want you to pause this, write this down in your graphing notebook. Percent over 100 equals a part over the whole. And then I'm going to show you one more thing that I want you to write down. This is just a strategy, right? And so I'm having you write that the strategy is to make a ratio table. And that's what we're going to use today to solve all of these problems. And I'm reminding you that to find the whole, right, to figure out in a word problem, which is the whole, you're looking for the words out of or total. And to find the part, it's the word is. So, usually when I give you some context, we can think about this. If I'm trying to figure out 75% of what number is 48, if I look at it as a test, and let's say I got 75% on my test, there's my percent of what number is the whole that's missing, because it's like the out of. And then this would be the part that I got right. So the part that I got right divided by the whole would give me the percentage, right? Remember how we would do the part over the whole, and then we would take the, I'm misspelling whole, we would take the part divided by the whole, that would be a decimal, and then we would have to turn it into a percent. So part over whole gives us a decimal, which we could change to a percent. But in this instance, I have the percent, I have the part, and I need to solve for the whole. That's what we're going to be practicing. Okay, so here is my first example, and here's the context. Helen got a 75% on her test, and she got 48 questions correct. How many questions were there on the test altogether? Right, it's that same thing that I was showing you on the other slide. So I've got a part to whole ratio table. And I know every time I have a percent, that takes up the whole column in my table. It's 75 over 100. And then this is so there's my percent. There's the whole that's missing. And this is the part that I got right. So I'm going to put 48 here in my part column, and then I am trying to solve for the missing whole. What was the total number of questions that were on the test? Now there's more than one way to complete this table and figure out the answer. And a lot of times we use this middle row, and we were finding greatest common factors, we were finding least common multiples. But today, instead of it is going to be strategic, but I'm not going to have to worry about the 75 and the 48 and look for some common factors. I'm going to show you a process that you can use no matter what numbers you have. Okay, so now I am strategic because I'm trying to figure out what the whole is. That's in my bottom row, which means to look for the pattern, I'm going to go to the top row. So here's my suggestion for today to make the process easy is I can always put a 1 in this middle row. And you'll see how easy it is to use 1 in your ratio tables, and we've done this before. And when I go from 75 to 1, the number's getting smaller. And if I'm dividing by a whole number, if I'm using whole numbers as my pattern, then I know I'm dividing because it's getting smaller. And I'm also dividing by 75 because any number divided by itself equals 1. I'm actually going to erase this part up here because it's getting in my way. So I just take the easy way out and I just go, oh, well, if I go from 75 to 1, it is a divide by 75 pattern. And if I divide by 75 on the top, I'm going to divide by 75 on the bottom. So now I have 100 divided by 75. I put this into my calculator and I get a funky number that repeats. And so I'm going to say, don't use repeating decimals. Don't use repeating decimals. Because with this, for instance, so when I take my calculator and I take 100 divided by 75, I get 1.3333. Okay, and it repeats, right? I don't want to use a repeating decimal, so I'm not going to put 1.333 in this box because that's not an exact number, and Mrs. Clifner is trying to get you to get an exact number. So I just put the 100 over 75. Now here's what I want you to remember. If you take 100 and divide it by 75, it's the same thing as saying 100 over 75. So it's kind of like I'm putting this division on hold right now. I don't want to divide and get a decimal because it was repeating. So I'm going to erase this part right here because I am going to need a place to do some work. Now, I know I need to divide, but it's not pretty when I put it into the calculator. So I just hold off. I write 100 divided by 75 because this fraction bar means divide. Now I go into the second part of the pattern. When I go from 1 to 48, it's times 48. If I multiply the bottom by 48, the top by 48, I have to multiply the bottom by 48. Now here's the cool part. Notice the pattern was, I didn't have to do any thinking about what's common factors and what's common multiples. I just took the 75 divided by 75, and then I multiplied by this 48. That told me the pattern. So now, when I go to the bottom, I didn't really divide by the 75. I just wrote 100 over 75, but now I'm going to multiply by the 48. Remember, when you multiply fractions, you have to put a 1 over underneath the 48 to make it a fraction. And now I just multiply across the numerators and denominators. 100 times 48 is my numerator. 75 times 1 is my denominator. I get 4,800 divided by 75. Now when I put that into my calculator, it is a nice whole number, and it's 64. So does it make sense? If I got 48 right out of 64 questions, is that 75%? And it does make sense. Okay, so I'm going to show you another example. Here's example number 4. This time I want you to see that it's greater than 100%, right? And so I just want you to know that the process that we're using works even if the percent is greater than 100. And so in this example, here is the context. Grab that. Sally got a raise. She earns 120% of what she normally earns babysitting each week. Her new weekly pay is $72. What did she used to make per week? So I want you to think about this one, right? What she used to make per week is the of what number. So this is my whole, which is missing. But remember, this whole that I'm going to put a big in my table, right? This is going to be missing, but this is less than the 72 that she started with because she got a raise. So from 72, this number should be smaller. So I go through and I go, okay, so there's my percent, 120 out of 100. And then it says is 72. So I know that this is the part. So in each of these problems, I have a percent, I have a whole, and I have a part. So remember, my advice to you is, instead of looking for common factors, let's just put a 1 here. When I put a 1 here, now I know my pattern is to go from 120 to 1, that is divide by 120. And then to go from 1 to 72, that is times 72. Whatever I do on the top, I'm going to do on the bottom. So I'm going to take the 100 and I'm going to divide by 120. And again, I put this into my calculator. If it's a repeating decimal, I'm not going to use it, and it is. So I'm just going to write 100 over 120 in this box. Don't want to turn it into a repeating decimal. And then I go back and I look at the next part of the pattern. The next part of the pattern is to multiply by 72. So here I go, 100 over 120 times 72 over 1. That is equal to 100 times 72 over 120 times 1, which is 7,200 divided by 120. When I do that math, I get 60 as my answer. So I was making, or Sally, sorry, was making $60 the week before. And then when she got 120% raise, sorry, it's not 120% raise. It's making 20% more than she did before. So if you think about it, her raise is 20%, right? Because she's getting paid 100% of her $60, but then she gets a little bonus of 20%. And that's why together she makes 120% of what she did before. Okay, now I've got some OYOs to try. So what I want you to do is when you create these tables, right, if you're doing this on your own, I'll just show you really quickly. Here's all, you don't have to get super fancy. What you want to do in your tables is you'll have this. You'll have a part, you'll have a whole. This will be the row where you put your percent. This will be the middle row where we work. And then with all of these, the whole is going to be missing. So that's how easy it is to set up the table. Okay, so I'm going to put this back and I'll go, you pause the video, go over these problems, and now I'm going to show you one by one. We'll go through these, but make sure you pause it and practice it on your own first. So I'm going to put P for part, W for whole. I notice it's 5% of what number the whole is missing, and I have a 10 there. So I'm going to actually move this down so I have a little bit of room to write. There we go, and I'll move that down. Okay, so I've got a part and a whole. Okay, so now that I have some room, this is my part, this is my whole. There's my part there. I put in 10. 5% is 5 out of 100. And then this is my missing whole. So here we go. I'm going to put 1 in the top middle row just because it makes my life easy. 5 divided by 5 is 1. That means I need to do 100 divided by 5. And I get 20. Ooh, that was easy, right? I didn't even have to use a calculator. There was definitely no repeating decimal. And then when I go from 1 to 10, it's a times 10. So I'm going to multiply by 10 on the bottom, and I get 200. So 10 out of 200 is equal to 5%. Number 6, 62% of some number. So I'm going to do my part and my whole, and this part is 31. The missing number is the whole, and I'm going to, oops, I forgot to put the percent. The percent is 62 out of 100, and I want to start with my middle column of being a 1. So from 62 to 1 is a divide pattern. It's divide by 62. So then I divide by 62 on the bottom. Now, this is one of those where if you take 100 and divide it by 62, it is not a pretty number. It doesn't look like it's repeating. It just looks like it goes on forever. So I just leave it as a fraction, and then I go to the next row, and I figure out the pattern from 1 to 31 is times 31. So this is also times 31. I'm just going to move this so I have room to do the math. I take 100 over 62, and I multiply it times 31 over 1. I multiply across 100 times 31 over 62 times 1. 3,100 divided by 62, and you should get 50. So if you got 31 out of 50 points on a test, that is a 62%. All right, let's do the other examples, and now I'm going to move this up to give me some room. Move those. Okay, same process. I'm going to start with the part and the whole, and then this time it's 60 out of 100. The part is 21. This time the missing number, well, just like every time, it was the whole. And I'm going to start by putting a 1 here in the middle. If I go from 60 to 1, my number is getting smaller. It is a divide by 60 pattern. So I divide by 60. 100 divided by 60 is not a pretty number, so I just leave it as a fraction. And then the last part of it is to do the multiplication pattern times 21. I multiply by 21. So let me move this over for right now. Here's what I got. I have 100 over 60 times 21 over 1. When you multiply the numerators, multiply the denominators, I get 100 times 21 over 60 times 1. Now I'm not even worrying about simplifying before I multiply because I'm using a calculator. All right, and I get 35. Okay, last one. Now this is one of those where the whole the percent is larger than 100. So I know when I get my answer to what my whole is, I know that it's supposed to be smaller than what I started with. So I'm going to label this part whole 120 over 100. The part is 48 and the whole is what's missing right there. I'm going to put a 1 in my middle row, and I know I need to divide by 120, and I divide by 120. 100 divided by 120, not a pretty number, so just leave it as a fraction. And then when I go to the last row, I need to multiply by 48. Maybe this problem is looking a little familiar to you, times 48. So I have 100 over 120 times 48 over 1. I get 4,800 divided by 120, and 40 is my answer. Okay, last two examples I want to show you look something like this. The width of a rectangular room is 80% of its length, and I'm asking you what the area is. And we can see right now that I'm giving you one of the measurements just by looking at this picture here, right? I usually call this the length, and I call the up and down measurement the width. So instead of part and whole in this table, I would have length and I would have width. So the length is 80%. Sorry, the width is 80% of its length. Oops, I just realized I wrote it the wrong way to understand this problem. Okay, so the tricky thing about this problem will be setting up which is the part. Oops, I don't like that color. Which is the part and which is the whole. So let's do this in red. So remember, I can do it. I can get a red color. So let's undo that. Let's undo that. There we go. Okay, so we're trying to think of a part to whole ratio. And so because it says the width is 80% of its length, that tells me that I want the top to be the width and the bottom to be the length. So when I set up the 80 over 100, it's going to make sense. If I try to do it the other way around, the length versus the width, it doesn't make sense with this sentence because it says the width is 80% of its length. And so the way I have it set up now is, well, if I look at this, this is the length. So for this one, they gave me the length. I'm going to fill that in red. So this is the length of 15. And it turns out that in this instance, the part is what's missing. But I'm going to do the same pattern of what I've been doing today. I'm going to show you how it works on the bottom too, right? So here's my 1. So to go from 100 to 1, I divide by 100. So that means I take the 80 and divide by 100. I get 0.8. And then I look at the next pattern to go from 1 to 15. It's times 15. So I multiply the 0.8 times 15, and I get 12. Now, all I found was the width. So I'm going to label this 12 feet. Now I have the dimensions. Now I can find the area. Remember, area of a rectangle is length times width. So I now have to multiply I'm not doing it in the right order. I need to do the 15 for the length. 15 times 12. Put that in the calculator and hopefully you get 180 feet squared. Okay. So here is an OYO. I want you to try this, but I'm going to show you that the setup is sometimes the hardest part. So because this time it says the length of a garden is 225% of its width, we're comparing the length to the width. So that is the correct order. And then it gives me the width right here is 4 meters. So this is 225 over 100. The width is 4. Okay, try this one. See if you can find the area of the garden. Go ahead and pause the video and try this. I'm going to put a 1 right here. Notice that. Oops, what silliness. Let's take that off. Let's make sure that we know that this is the missing number. See how easy it is to make a mistake. This time the missing number is up there. So I need to put my 1 right here. And then I start the pattern. I divide by 100. Divide by 100. You should get, let's see, 2.25. And then the next pattern is to go from 1 to 4. Let's use blue. When I go from 1 to 4, it's a times 4. 2.25 times 4, and I get 9. So the length is 9 meters and the width is 4. Area equals length times width. So it's 9 meters times 4 meters, which equals 36 meters squared. Okay, last Oyo. Try, I'll do an example for you, and then I'll show you I'll just open the OU right now so you can see it. Okay, so remember that this is kind of like what we did last week. Remember, of means times. So I'm trying to figure out, I wonder if we're using the less than symbol, the greater than symbol, or the equal to symbol. So if I'm trying to figure out what 70% of 80 is, remember I take the 70 and I divide by 100 and I get 0.7. Of means times, and there's my 80. So I'm basically multiplying 80 times 0.7, and I get 56, and then I'm going to compare it to 80% of 70. So I take 80, divide by 100, and it equals 0.8, and then I multiply by 70, and maybe you see the pattern that the numbers appear to be the same. So I get 56 on both sides, and those are equal to each other. So pause the video and try this next example, this next OU on your own, number 10. Nothing like that. Okay. 92 divided by 100 equals 0.92, and then I multiply by 30, and I get 27.6. And on this side, I do 48 divided by 100 equals 0.48 times 75, and I get 36. So the symbol that I want to put in is the less than symbol, and the way I say this is 27.6 is less than 36. Okay, that's it.